Hi everyone. Good morning, good evening, good day to the world. I'm delighted to introduce Jean-Charles Souriau from CEA-Leti. He's project leader there, and today he will tell us a bit about ultra-thin flexible ICs for flexible electronics. Jean-Charles, over to you.
Okay, thank you very much for the introduction. And hello everyone. So I am glad to present our development on ultra-thin flexible ICs for flexible electronics. So this is the outline of my presentation. First, I will present the context of a study, and I will talk about flexible electronic technology to build flexible systems. In the second part, I will present the ChipInFlex technology we have developed in Leti in order to embed the ultra-thin silicon die in a flexible material. In the third part, I will present the test vehicle and demonstrator we've made to validate this technology. And finally, I will conclude my talk. So first of all, regarding the market for flexible electronic systems, so we think that major market are for electronic for consumer, and as example, you have here the smartphone. It's a foldable smartphone. So in this case, flexible electronic is important. Also, we have some other application for electronic glass. One important market concerns also medical application and wearable devices. For example, the health patch are an important application for us because it's allowed to measure physiological parameter on the body. Automotive is also important market, specifically when you want to implement a function on a board or on steering wheel. E-textile, it can be also mentioned, so you can add some electronic in textile in order to measure environmental parameter or to have a RFID die on the textile. And the last one I mentioned here is robotic, because we want to implement a lot of sensor on the surface of the robot, and so flexible electronic is also important in this case. So regarding our motivation, in fact, we want to be able to add more functionality on any product without to change its aspect. Okay. So in fact, we would like to make some kind of electronic label in which you can have a different component, sensor on ISIC, and this label can be put on any object or also on human body. So in this case, you don't change the aspect of the object, and the function can be to capture information, to operate, to iterate, or to communicate. Okay, so now regarding the technology, so there are two families of technology. The first is without silicon component. So this technology is a printed electronics. So we can print organic transistor, we can print sensor, we can print actuators, antenna, or electrical networks. There are a lot of things we can print. And the second family concerns flex with silicon component. So here there are three categories. First, you can have a component already packaged, and you can bond this package on a flex. So in this case, you will have flexibility only between the package. The second case concerns the silicon die on a flexible substrate, like a TEAG RFID, or in an example here, it's also silicon die on PN film. And the last one, which is more in development in laboratory, concerns thin silicon die, which are embedded in flex. In this case, everything is flexible. The flex of the electronic network, but also the silicon, because the silicon is thin below 100 micrometers.